In part 1 of this lesson, we looked at how to represent data for one categorical variable graphically. We used pie charts and bar graphs. Now we're going to look at how we represent data for two categorical variables. And we can use a two-way frequency table. Two-way frequency tables are used to display data for two variables recorded from a sample. And by calculating some chosen percents, we can see the relationship between these two variables. So let's look at an example. This is an example of a two-way table from page 12 in your textbook. It says a survey of 4,826 randomly selected young adults aged 19 to 25 asked, what do you think the chances are you will have much more than a middle-class income at age 30? The table below shows the responses. As you can see, in the columns here, we have represented one variable, gender, female and male. Along the rows, we have 5 variables, their opinions of whether or not they'll be rich. We have almost no chance, some chance, but probably not, 50-50 chance, a good chance, and almost certain. Let's take a closer look at the anatomy of a two-way table. So, in each of these squares in the center of the graph represents the counts for each combination of variable. So for example, the number of people from the sample who were female and felt there was almost no chance of getting rich are 96. Those are the counts. Now here, in this vertical column here, we see all our row totals. So we know the total number of people in the sample who said there was almost no chance of getting rich was 194, while the chance of almost certain that they would get rich is 1,083. That's our row totals. Here are our column totals, which tell us the total number of our gender variables, 2,367 female and 2,459 male. And this final block right here, 4,826, tells us our table totals and exactly how many people participated in this sample. Let's go over what a marginal distribution is. The marginal distribution tells us the distribution of each individual variable for the sample, calculated from the totals along the right margin of the table and the bottom margin of the table. So let's do an example. We can find the marginal totals for gender by finding simply what percent of participants were female and what percent were male. If I divide 2,367 by 4,826, I get 49% and 51% for male. As you notice, these 2% should add up to 100%, as it represents all people in this sample. I want you to take a moment and figure out your marginal distributions for opinion. So this column here, you want to find your marginal totals. Let's take a look at conditional distributions. Now, marginal totals can tell us what percent of individuals in our sample fell within each category, but they can't really tell us what the relationship between the two variables are, and that's when the conditional distribution comes into play. It describes the value of one variable for individuals with a specific value of the other variable. It also allows us to see the relationship between the two variables. So let's take a look. This example says, calculate the conditional distribution of opinion among women. So what I'm going to do is I'm going to go to the column for women, female here, and then I want to find all the distributions for each of the opinions for women. And so that's what we've done. We've found that 4.1% of women say there's almost no chance, 18% of women say there's some chance, and etc. As you can see, my condition is that I'm starting with gender. I know that these people are female. If they are female, now I want to see what's the chance or what's the likelihood that they have a certain opinion. And that's a conditional distribution. We could also do this the opposite way. And instead of going by female, we could go by opinion and find the conditional distribution of opinions. So let's see what this looks like. It says, calculate the conditional distribution of gender among the opinion almost certain. So I go to almost certain, I have my total is 10,083, and I find, okay, what percent of women, or what percent of people who believe that it's almost certain that they would be wealthy are women, we get 44.9 and then 55.1%. And so that is a different conditional distribution that we were able to calculate from this table. Now, if we want to actually see the association or the relationship between the two variables, you have to compare conditional distributions. This allows us to see whether one variable explains changes in the other variables. So here we have both the conditional distribution for opinion among women and opinion among men. And this is going to help us see whether there's some difference in the way that gender affects my opinion on whether or not I'll be wealthy. As you can see, here they have very similar percentages. Here, for some chance but not likely, women seem to be more likely to have this opinion than men. And then if we look here, men seem to be more likely to think there's a good chance or almost certain that they will be wealthy compared to women. So here they've made a side-by-side bar chart where you can see the percentages on the side. Obviously, it wouldn't be good to use counts because there are different numbers of men and women in the sample altogether. Percent allows us to see how they actually compare. And here we see that, again, men tended to feel that there's a good chance or almost certain more so than women. Let's read their analysis here. Based on the sample data, men seem somewhat more optimistic about their future income than women. Men were less likely to say that they have some chance but probably not than women, 11.6 versus 18%. Men were more likely to say that they have a good chance, 30.8% versus 28%, or are almost certain, 24.3% versus 20.5%, to have much more than a middle class income by age 30 than women were. And then one last way of representing this data is a segmented bar graph. As you notice, both graphs go up to 100% because this represents 100% of women in the sample and 100% of men in the sample. But each color represents the different opinions. And as you can see, these purple and red opinions, which represent the positive opinions about the future, tend to be slightly more for men than women. So why is this important? By comparing conditional distributions, we can often see if there's an association between two variables. And if there is an association between the two variables, then we can say knowing the value of one variable helps predict the value of the other variable. So knowing that someone is a man helps us predict that they're more likely to have a positive view of their wealth in the future.